Okay, good morning to one and all. The previous class we have finished unit 3, that is the potentiometers and bridges. We have already finished that one. So we are going for the next topic, that is called transducers and instrument transformers. This is the unit 4 here. So I have already given the assignment of unit 3. All of you write down that one. And SYA student, I have already posted a link for the assignment upload. You people who submit the assignment already, it is finished for you peoples. And for the P division students, have you taken the questions for assignment number 3? Anyone, can you reply? Do you have the questions for assignment number 3?
No, sir.
No. Take question assignment number 3 and as well as 4 also today. The 4th unit also I will give now only. So the assignment number 3, you write down that first you have to explain the, what is that, principle of DC potentiometer. The first question you write down. Explain.
Sir, assignment 3 झाले.
DN already assignment 3?
हो sir.
Then some people they are telling assignment number 3 nahi diya bol ke. Starting only I have given, I think, yes.
Yes sir.
Okay. 35, 32. So before starting the syllabus only, I'll give the 4th assignment. You take down the 4th assignment. Assignment 3 already given, means assignment number 4. Before the introduction of chapter 4, I'll give the assignment first. Write this one. Give the classification of transducer. Question number 1. With need sketch, explain the strain gauge. Strain gauge, don't write that strain gauge. It is not there now, syllabus. So explain current transformer with need diagram. Question number 1 you take down. Question number 4 you take down. Okay. Turns combinatorial, reduce the ratio error. Phasor diagram. This one. Question number 8 you take down. Question number 9. 1, 4, 8, 9. 1, 4, 8, 9. 13, 16. Define the following terms: the transformation ratio, nominal ratio, turns ratio, burden of 16. लिख रहे क्या नहीं? Okay, only 17 questions are there. Out of 17, you take 16th one you have to write down, and 13th you have to write down. Next, which one? This one also you take down. 12 also, right? The advantages and application of instrument transformers. And 10 MCQs. Is it clear? Once again, I will repeat. Question number 1, give the classification of transducer. Question number 4, explain the current transformer with need diagram. Next, this one, draw typical phasor diagram of potential transformer and derive expression for actual transformation ratio. Question number 8. Question number 9, difference between CT current transformer and potential transformers. Question number 12, write the advantages and applications of instrument transformer. Question number 13, draw the phasor diagram of current transformer and derive the expression for actual ratio and phase angle error. Next, question number 16, directly define the following terms as applied to instrument transformer, that is transformation ratio, nominal ratio, turns ratio, burden of an transformer. कितना questions हो गए total? 2, 3, 7 questions. Okay. These 7 questions you write down, as well as 10 MCQs you have to write down in the starting. और 2 क्वेश्चन दे दो क्या? बस हो गए?
बस सर.
ओके. So the topic name is transducers and instrument transformers. The unit 4, that is section 2, we have started. So the transducers are nothing but so many transducers are there: actual active, passive, physical, secondary, primary transducers, and electrical transducers, mechanical transducers, the analog transducers, digital transducers. Actually, yours branch is electrical, so we are going to concentrate much on electrical transducers, which converts the physical quantity into or any other form of quantity, one form of energy, one form of energy to another form we are going to call that. So physical quantity into electrical quantity, which one? Or physical or mechanical quantity into electrical quantity, that one we are going to call electrical transducers here. So we'll discuss definitions also, just for your understanding. Your branch is electrical, so we are going to concentrate on electrical transducers only. But again, we should have to know that one, the mechanical transducers are different, active transducers are different, passive transducers are different, analog transducers are different, digital transducers are different. Okay, that is one part here. Now it has 2 parts. One is transducers, another one is instrument transformers. Actually, for the measurement purposes, we are going to use the instrument transformers in the substation and all the things. 220 kV, 440 kV, wow, very higher voltages are there. Directly we cannot put the voltmeter over there. For that reason, for the measurement purpose, we have to reduce that voltage to 100, 120, 200 volt. We have to reduce that one. So for that reason, we are going to use the potential transformers. And to reduce the current, we are going to use current transformers here now. So instrument transformers are 2 types, that is potential transformer and current transformer. We are going to discuss about that one here. So this is how it has 2 parts, that is transducers and instrument transformers here. So the syllabus for this unit 4 is, first we are going to discuss about resistance temperature coefficient or temperature coefficient of resistance, or RTC we are going to call that one. I think you have heard this name, resistance temperature coefficient. Per degree change of temperature ko how much the resistance will change, that is nothing but resistance temperature coefficient we are going to call. This one we are going to consider as alpha. We are going to denote it that one. We'll discuss that. Derivation is there, not derivation, how what is the relation between resistance and temperature, we'll discuss for different materials. Next, first the RTD is there. Next we are going to go discuss for the classifications of transducers, whatever I told that now: analog, digital, active, passive, electrical, mechanical, and primary, secondary, like this we are going to discuss this one. These are all the classifications of transducers we are going to discuss. After that, we will go for particularly electrical transducers, that is resistance temperature detector, that rotational variable differential transformer, linear variable differential transformer, that is LVDT, RVDT, RTD. These 3 types we are going to discuss in this chapter. And this part, it completes it has 2 parts I told. Actually 3 parts are there. This 2 parts are related to the transducers, this classifications of transducer, and this is transducers. And the first part is that is related only for the RTC, that is the resistance temperature coefficient. That is very basic actually. To understand RTD and all the things, this one is necessary. For that reason they have added. And from this part to this part, it is completely related to the instrument transformer, is nothing but CT and PT is there here. Okay, so this is the syllabus of the unit 4 here now. So we'll start the first one, that is called resistance temperature coefficient. We are going to discuss here now. So the definition I told, the resistance change factor per degree Celsius of temperature change is called temperature coefficient of resistance here. See here, suppose initially there is around, suppose 100 ohm resistance is there. Okay, 100 ohm resistance is there. Just imagine 100 ohm is there for around 40 degrees Celsius temperature. Okay, 40 degree Celsius temperature here now. We'll call that one. Okay, suppose for the 41 degree Celsius, the resistance is changed or not. That matters here now. Resistance temperature coefficient. For the 41 degree Celsius, if the resistance is 90, then it is not linear. It is opposing each other here. If it is for 110, then what we can call that one, the resistance increases, then temperature also increases. That is linearly proportional RT, resistance and temperature. So for degree change, there is change in the resistance here now. This one or this one, it may be increase or it may be decrease. The resistance value may increase or decrease. But for degree change of temperature, the resistance is changing. That is called, we are going to call that one as temperature, resistance temperature coefficient or temperature coefficient of resistance. Both are same only. That is called RTC. We are going to call that. See the definition, the resistance change factor per degree Celsius of temperature change here now. Resistance change factor, resistance change हो रहा है क्या नहीं? When per degree Celsius temperature change here now, 1 degree Celsius temperature change हो गए तो the resistance is change. That is called temperature coefficient of resistance or resistance temperature coefficient. That is both are same. This factor is represented by a Greek lower letter that is called alpha. That is called alpha. We are going to call it. Is it clear? Definition. 1 degree Celsius temperature change हो गए तो the resistance is changing or not. It is whatever it may be increase or it may be decrease. But it should have to change or not. We have to check that one. Is it clear? Yes.
Yes, sir.
Okay. So this is just a definition here now, just definition for resistance temperature coefficient. 1 marks question may come over there. This definition they will give, and it is called as RTC, RDT, RVDT, LVDT. You have to choose the correct answer one. Okay. See here, this is the formula we are going to consider. There is the total resistance here now, change of resistance, that is called reference resistance is nothing but initial resistance we are going to consider. 1 plus alpha is nothing but RTC, how much it is, RTC factor is there, and initial final temperature, that is initial temperature here now. From this formula, anyone, can you tell me the formula for a resistance का formula है हमारा, total net resistance equal to, that is change in resistance equal to, this is the formula. Can anyone, from using this formula only, can anyone tell the alpha derive, this one alpha equal to, derive and tell the formula? Any one of you कर सकते क्या? Will you do this one? Can you tell the formula for alpha? Roll number 12 and 14. Hi, get roll number 12. B division, not A division. Roll number 10 and 12. Okay. Not 14, 10 and 12. Are we there?
Yes, sir.
Derive the equation for alpha, same by using the above equation. Okay. So alpha equal to, can anyone tell the formula? Already we have studied this one. Any one of you? कर रहे क्या? मैं explain करूँ वो बोलो पहला. If any one of you people are doing, then I will wait. Otherwise, I will explain that one. If anybody is doing, give the reply. Unmute and give the reply. Nobody. क्वेश्चन पूछने का ही गलत है आप लोगों को. क्वेश्चन भी नहीं पूछ रहा हूं मैंने, इसका सॉल्यूशन आप करने वाला है क्या? मैं करूँ वो बोल दो एटलीस्ट. एनी वन ऑफ यू? अरे बाप रे, इतना भी नेग्लिजेंसी नहीं रहना चाहिए. ऑल ऑफ यू अनम्यूट. अनम्यूट करो. कौन म्यूट में रहते हैं उनको रिमूव कर देता हूं मैं मीटिंग से बाहर. अनम्यूट फास्ट.
मास्कर सर.
Who will not do the unmute? Remove them from the meeting. Roll number 4, 3, 2, Wind Division. Twenty-four. अनम्यूट तो सब लोग करते हैं, बट बोलने के लिए क्या प्रॉब्लम है फिर? What is the problem with you people to tell them? So see here, this R reference we have kept outside. So you have taken common here now. You send into inside this bracket here now. So R reference into 1, that is called R reference. It is going to happen. That is reference voltage or initial value we are going to call plus alpha T minus T reference. Here plus symbol I will use RTC. Alpha into R reference I will write here now. Alpha into R reference and T minus T reference here. T minus T reference we are going to call that one. Okay. Now you send this one into LHS side here now. Here R is there, here plus is there. When I will send into LHS side, it will become R minus R reference. It will become R minus R reference. It will become and equal to this alpha R reference T minus T reference. You will write that one here. Now we want this alpha equal to. So then this whole term I will send into opposite side. It will become here the numerator multiplication is there. When you will send into multiplication factor into the opposite side, it will go into the denominator here now. So alpha equal to, what is the opposite term here now? R minus R reference. I'll write as it is R minus R reference. R minus R reference divided by this term we have to write here now. R reference into T minus T reference here now. This is the alpha formula. Actual alpha formula is, this is the alpha formula here now. Resistance temperature coefficient formula is this one. Okay, see here the R is conductor resistance at temperature T degree here. T degree को कितना temperature है we are going to measure here. And R reference is the conductor resistance at reference temperature, that is called T reference, usually 20 degrees Celsius, but sometimes it is 0 only here. 0 भी ले सकते दिस टेम्परेचर here. Alpha is the temperature coefficient of resistance for conductor material and T is the conductor temperature in degree Celsius. How much conductor का temperature कैसे degree Celsius increase होगा क्या decrease here. And T reference is the that is reference temperature for the alpha specified at the for the conductor material. So this is the alpha formula we have derived here now. See here, this R reference is initial temperature. This is the final value. Suppose here we are going to consider here now. I will consider this x-axis as temperature here now. X-axis is temperature. R-axis is that is resistance. I will use the temperature. I will use this is 10 degrees Celsius. This is 20 degrees Celsius. And this is 30 degrees Celsius. You can consider that one. Initial, the reference resistance is 0. Suppose suddenly for the reference, the temperature is around 50 is there. For the 20 degrees Celsius, the reference resistance for the resistance will be here initially 50 है 20 degrees Celsius को क्या हो गया ये 100 हो गए. सोचो अभी आप can consider that is 100. Okay, it is increased now. For 20 degree, it is increased. We can think that one here now. So on that condition, you can put your value here. Initial, the now final value is 100. So what is the net change of the resistance? Final value is 100 minus initial value. कितना हो गए? 50. 100 minus 50. How much it is?
50.
50. Next here initial temperature is 0 and the final temperature is 20 here now. 20 minus 0?
20.
So this T minus T reference is 20 degrees Celsius. Into initial temperature is that is 50 only. We can 50 give 50 get cancel 1 by 20. We can write the answer. That is the RTC. We can tell that one here. Like that we have to actually this T minus T reference means final value net change of temperature. Here net change of resistance here. So per degree Celsius change of temperature ko the resistance is changing here. Yes or no? If the resistance is changed, then the temperature is changed, the resistance is also changing that one. So the definition we have proved here now by using this one here. Next one, see here. The positive temperature coefficient and negative temperature coefficients are there here actually. The positive temperature coefficients, what it is going here now. If the temperature is increasing, the x-axis is temperature here now, and y-axis is that is resistance is there. The resistance of the conductor is directly proportional to the temperature. We are going to call that one because linearly positive temperature coefficient, what will happen for the increasing temperature, the resistance is also increase हो रहा है ना. इधर resistance कितना है, इधर initially कम है, next temperature increase होगा, इधर ज्यादा होगा, इधर ज्यादा होगा, the temperature resistance is also increasing here. Yes or no? For increasing temperature, the resistance is also increasing. So that type of the temperature that is called positive temperature coefficient, we are going to call that. For increasing temperature, resistance is also increasing. That is called positive temperature coefficient. Can anyone tell the conductor material, which one the temperature increases means resistance will also increases? Which materials we are using for that one? Metals are there, alloys are there, and what is that one? Copper, aluminium, rubber. This out of these material, which one is applicable that for positive temperature coefficient? In your houses, which type of conductor you are going to use? हाउस वायरिंग के लिए कौन सा कंडक्टर यूज करते हैं आप? मटेरियल फॉर द कंडक्टर वायर है ना. हाउ सबका घर में इलेक्ट्रिसिटी सप्लाई इज देयर और नॉट? हाँ, आप लोग वायर खोल के देखा है क्या कभी? तो
Yes, sir.
व्हाट व्हिच मटेरियल वी आर यूजिंग ओवर देयर?
Copper.
Copper. That is the copper copper, aluminum, any metal parts, we are going to call that one. If temperature increases, then the resistance of that material will also increases here. उसके लिए बोलते देखो घर में हीट हो गए तो हीट बोर्ड हीट हो रहे बोल के. If it is heating, the resistance will increases, current will start to decreases. Again resistance increase हो गए, whatever the insulation है, it will breaks over that one, then short circuit will occur over there. That is a loss problem it will create over there. So the resistance positive temperature coefficient we are going to call that. If the resistance is increasing with resistance is increasing for increasing temperature, that is called positive temperature coefficient. We are going to call that one. See here I have written here same thing. A positive coefficient for material means that its resistance increases. The resistance of any material, it increases with an increase in temperature here. Now if the temperature increases, the resistance will also increases. So the material for that, the positive temperature coefficient is pure metals typically have positive temperature coefficient of resistance here. The metals are there, that is positive temperature coefficients we are going to call. Example, aluminum, copper, we are going to use that one. Metal parts, aluminum, copper. Any doubts? Any doubts? I am asking to you people only. Doubt hai to pucho at least. So this is positive temperature coefficient. Next we will go for the negative temperature coefficient in the reverse. Here the positive temperature coefficient, what is happening? The resistance is increasing. Then temperature increases means resistance is also increasing here. But for the negative temperature coefficient, initially it has high resistance. When the temperature increases, its resistance value will start to decrease here. Like that, the materials are there here. See here, the initial condition at 0 degrees Celsius of temperature. See, I will draw here only. This one. Visible hai kya? At 0 degrees Celsius temperature, the resistance is very high. Jaisa temperature like increasing, then the resistance will start to decrease here. The resistance will start to decrease here now. If the high temperature, then the resistance will completely decreases here now. Can anyone tell the material for this one? Which type of material have a high resistance initial condition? Yes. क्वेश्चन ही मत पूछो सर ऐसा सिचुएशन में आप लोग. क्वेश्चन नहीं पूछने का बोल रहे हैं आप लोग. इतना डिस्कशन डिस्प्ले करने के बाद तो बोलो एटलीस्ट. Have you studied the semiconductors? Semiconductors have you studied?
Yes, sir.
ए डिवीजन स्टूडेंट, आपको भी रिप्लाई करने के लिए नको नहीं बोला मैंने कभी भी. You can also give the reply. You have already studied this one, given the chapter test and all the things. So the negative temperature coefficient materials means that is called semiconductors we are going to use. Semiconductors example, initially we can take the any SCR material or diode or LEDs, we can take that one. So if the temperature is increased, that one, the resistance will be decreases, or initially they will oppose the flow of current. They have very high resistance, but after some time they are going to conduct that one by passing a current and all that. So the negative temperature coefficient is applicable for the semiconductor materials here. Initially they have high resistance, and slowly if the resistance increases, the temperature increases, the resistance of that material will start to decrease over there. So a negative coefficient for a material means that its resistance decreases with an increase in temperature. It is reciprocal or opposite to the positive temperature coefficient. For the increasing temperature, resistance will increases, positive temperature coefficient. For increasing resistance, the temperature, resistance will decreases, that is called negative temperature coefficient here. So the example for that one is semiconductor materials, carbon, silicon typically have negative temperature coefficient of resistance. And one more I will ask that one. So some materials they have the resistance at 50 here now, 50 here now, like this they are having here. For increasing temperature, kitna bhi increase karo aap, it will not change its resistance value here. They will become constant only. The resistance of that type of materials, it will not increases at all. What are those type of materials? Can anyone tell me? Sunat hai at least. It is not there in your syllabus, then also I am taking because just for your knowledge here. No, some materials are there, conductor materials, its resistance is constantly, whatever it may be, a resistance, temperature, it may be increase or decrease, but it will have maintained its resistance constantly. Constant and manganese, some materials are there, constant and manganese, two materials, they will maintain their resistance constantly. They will not change for increasing temperature or decreasing temperatures over there. Okay, it completes the RTD, that is called resistance temperature coefficient. It completes here now. So if you have any doubts, questions, you can ask here now. Resistance temperature coefficient definition we have discussed. After that one, that formula and positive temperature coefficient, negative temperature coefficients. If you have any doubts, you can ask.
हॅलो सर.
हा बोलो.
सर आपला जो हीटर असतोय इलेक्ट्रिकल हीटर, तर तो सर पॉझिटिव्ह टेम्परेचर कोएफिशियंट मध्ये येतो का निगेटिव्ह?
Which one?
इलेक्ट्रिकल हीटर सर पॉझिटिव्ह टेम्परेचर कोएफिशियंट मध्ये येतो का निगेटिव्ह मध्ये?
Positive temperature coefficient मध्ये येते. Then only your water will start to heat, na?
हा सर.
Then current, jaisa resistance will decreases, then current it is going to increase in that one. That is inductive coil actually.
Okay sir.
Aluminum part only we are going to use, na? Aluminum or copper part.
हा sir.
Yes. Next. Anyone? Any doubts?
No sir.
That this one I am expecting actually. If you have the doubt, you ask. Otherwise, you have to tell no at least to proceed for the next. Otherwise, I will stop here only. So we'll go for the next step, that is called transducers here now. So transducers is nothing but the general definition of the transducer is it converts one form of energy to another form here. One form of energy is converting into another form. Particularly when we will go for the electrical, then the physical quantity is converting into electrical quantity. We are going to call that. Physical quantity is converting into electrical quantity. The general term of definition is transducer is a device which converts one form of energy to another form. We are going to call that one. That is general term. General definition of the transducer. We are not concentrating on mechanical, electrical, and all the things. Okay. So that is nothing but what we will do, physical to physical, it may be physical to electrical, or electrical to physical, or mechanical to electrical, physical to mechanical, mechanical to electrical. It may be anything. That is called general definition of the transducers. Okay. So the examples are strain gauges are there, thermocouple, thermistors are there, RTD is there, RVDT is there, LVDT is there. So many devices are there. So many devices are there. So this is the definition, general form of transducer definitions. So this is the block diagram of transducers. Here one form of energy we are giving into input, and the transducer it is converting into another form of energy. Example, for the thermistor, we are giving the temperature input. Temperature we are going to give the input, but the output we are going to get in the form of resistance here. So temperature is a physical quantity. Yes or no? temperature is a physical quantity, resistance is electrical quantity. Yes.
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 One form of energy is converting into another form. Just I have given the example here. So this is transducers definition here. Next, we will go for the classifications of transducers. The classifications of transducers, actually transducers are classified into according to their applications here. Active transducers, passive transducers, analog transducers, digital transducers, primary and secondary, electrical and mechanical, transducers or inverse transducer. This is actually whatever we have discussed just now, that is same definitions. This will not, all the things are same only here now. Definition is same, but name as per application we have given the name differently we have given here. So one by one we'll discuss here. Now this is the classifications of transducers here. The question assignment question is given, remember that one. Active, passive, analog, digital, primary, secondary, electrical, mechanical, and transducers are inverse transducers here. So active transducers is nothing but to give the supply. Suppose we are going to convert something. So on that situation, it requires external power supply here now. So that is nothing but passive. But external power supply ka jarurat nahi hai. That type of transducers we are going to call as active transducers. The transducers which does not require the external power source is known as active transducers here. We no need to give the external electrical supply like that, but then also it is going to convert into, that is, one form of energy into another form here. Such type of transducers are called as, that is, active transducers we are going to call that. So such type of transducers develop their own voltages or current, hence known as self-generating transducers we are going to call them. They are going to self-generating transducers we are going to call them. So examples for that one, piezoelectric crystals are there, PV cells, solar energy, you consider the solar panel. Solar panel को आप supply दे रहे क्या? You are going to use solar supply for the solar?
No, sir.
Then how it is going to convert the heat energy into electrical energy, light energy into electrical energy? It is taking the light from the sun and it is converting into electrical. Yes or no?
Yes, sir.
So like that we are going to consider here now. So the transducer which does not require the external power supply, it is not required, then also it is going to convert one form of energy into another form, that is nothing but physical form of energy quantity into electrical quantity. Such type of transducers are called as the active transducers we are going to call here. Now they are self-generating transducer. They are also called as self-generating transducers here now. So the output signal is obtained from the physical input quantity here now. So the examples for that one, piezoelectric, piezo material is there. Whenever we will fold like this, it is going to generate the electricity. That is also piezo material. I don't know how many of you heard that one. Photovoltaic cells are there, tacho generators are there, thermocouples are there, photovoltaic cells are the example for that. Is so PV cells or solar cells we are going to call that one. So that is active transducers. Next we will go for the passive transducers. The transducer which require the power from external supply source is known as passive transducers. इसको external power supply is का required or जरूरत है. That is called what we are going to call passive transducer. There are also known as external power transducers here. These are also called as external power transducers. The examples is nothing but thermistor, strain gauges are there, and see here now I will give one example, that one here. Your temperature now during the COVID situation, some light energy they are going to pass and they have observed your temperature. So इसको अंदर battery डाला वाला है रहते ना, this cell, yes or no, external supply is there?
Yes, sir.
That is examples. It is going to sense that one, transducers here. Next, analog transducers here now. So active and passive, you have to remember one which does not require the external power supply, that is called active. Required external supply, that is called passive. Okay, and active transducers are also called as self-generating transducers. Passive transducers are external power transducers, we are going to call them. Next, analog transducers here. Analog means what it is. Previously, suppose आपके घर में watch है, analog watch है ना, वो कैसे point wise it is going to move over there. Yes or no? It is analog only.
Yes, sir.
But while doing that, the watch, is there end for that watch? वो किधर तो end है बोल के ऐसा है क्या? Continuously it is going to rotate in this form only. Continuous function is there, yes or no? But for the digital, you consider that one. Around 60 units होने के बाद वापस 0 को आ जाते. It will reset into 0, 00. But the analog is not like that. It is continuously, it is going to operate 111 bit, it is going to shift over. So analog is nothing but continuous function, we are going to call that one. So the analog transducer changes the input quantity into a continuous function, it is not. Changes its input quantity into continuous function, it is going to change. That is called, again, the strain gauge is the example, LVDT is the example, thermocouple is there, thermistors are the example of analog transducers. I will show the LVDT. LVDT will discuss about that. Okay, that is analog here now. The digital is nothing but analog. Whatever the input quantity it is there, it is converting into digital signal. In the form of pulse, it is going to give that one here. So these are the physical quantity is converting into digital form, digital energy or digital quantity. That is called digital transducer. We are going to call here now. So the signal. Digital signal works on the high or low power. The power supply is required for this one. This is a passive transducer, and the optical encoder is the example for this one. So this is analog and digital here. Now it is very important here now. The primary transducers and secondary transducers. Primary transducers are called as mechanical transducers. We are going to call it here. It consists both the mechanical energy and as the electrical devices. It is going to consist here. So the mechanical devices of the transducer here, the transducer consists the mechanical as well as electrical devices here. It is consist of both electrical and mechanical here devices. So the mechanical devices of the transducer changes the physical input quantities into a mechanical signal. So primary transducer is nothing but it converts physical quantity into mechanical energy here. Physical quantity into mechanical energy. So mechanical quantity we are going to call that. So that is called primary transducer. Example for that one is Bourdon tube and all the things they have mentioned. But the secondary is important for us because the secondary transducer, it is going to convert this mechanical quantity into electrical quantity. Understood? Primary transducers, they are converting physical quantity into mechanical. But the secondary transducer, they are converting the mechanical signal into electrical or mechanical quantity into electrical quantity. समझ में आ रहा है? Primary and secondary. Primary, suppose one physical quantity is there. That one we are going to convert into mechanical first. That is called primary second year. That output of this primary is converted into electrical. That is called secondary transducer. Is it clear concept?
Yes, sir.
So second primary is converting first physical quantities converting into mechanical here now. Then that mechanical quantity or signal is converting into electrical signal. That is called secondary transducers. We are going to call that. That is called secondary transducers here. So the magnitude, the secondary transducers converts mechanical signal into electrical signal here now. So the magnitude of the output signal depends on the input mechanical signal. The output signal of the electrical is depends on the mechanical input signal here now. So this is the primary and secondary transducers we are going to call here. Primary transducers and secondary transducers here. Now that definition came here now, that is called transducer. What do you mean by transducer? जनरल अभी स्टार्टिंग में बोल दिया मैंने, वन फॉर्म ऑफ एनर्जी इज converting into another form. But when we are studying specific electrical branch we are considering, on that condition we have to tell the definition specifically for electrical appliances. So the transducer, it is a device first. It is a device which converts non-electrical quantity into electrical quantity, is known as transducer. That is called electrical transducers, or only transducers we can call that one. Non-electrical quantities, it may be physical, it may be mechanical. It is non-electrical. Physical is nothing but non-electrical only. Mechanical is nothing but non-electrical only. So in the overall general we can say that one, the transducer is a device which converts non-electrical quantity into electrical quantity. That is called transducer. That is called the transducer. But inverse transducers, what do you mean by inverse transducer? Here non-electrical quantity to electrical we have considered. Its inverse क्या हो जाएगा इसका? Its inversion of this one. Yes. Here non-electrical quantity into electrical quantity, it is converting the transducer we are telling here now. Its inverse, what is the inverse of this one? Input will become output, output will become input. Can anyone say?
Electrical to non-electrical.
Electrical to non-electrical. The non-electrical may be mechanical or physical, that is here now. So the inverse transducer is nothing but which is going to convert electrical quantity into non-electrical quantity. It may be physical quantity or anything here. Such type of transducer is known as an inverse transducer here. So same thing they have written here now. The transducer which converts the electrical quantity into physical quantity. Physical is nothing but non-electrical only. So such type of transducers is known as the inverse transducers here. So the transducer has high electrical input and low non-electrical output here. Input is very high, but the output is very low here now. For the transducers, this is inverse transducer ho gaye. For the transducer, the input is low, output we are going to get high, because which side electrical is there, that is high output we are going to get over there. So the last point, that is electrical transducers and mechanical transducers. Just now we have discussed the physical transducer, primary transducer and secondary transducer. Same definition is there for the mechanical transducer. The primary transducers are also called as mechanical transducers we are going to call. In this one, what we will do, we are converting the physical quantity into mechanical quantity. Physical quantity into mechanical here now. It is a device. Mechanical transducer is a device which converts any physical quantity into mechanical quantity, or mechanical quantity into physical quantity. That is called mechanical transducers we are going to call here. Especially it is physical quantity to mechanical quantity is the correct answer. But in the definition they have mentioned physical or mechanical quantity into mechanical or physical quantity. But I will tell, don't get confused here. No, the mechanical transducer is also called as primary transducer. It is a device which converts physical quantity into mechanical quantity. That is called mechanical transducers. The output we are getting in the mechanical form, the output we are getting mechanical signal, mechanical quantity or mechanical energy. That device, that transducer is called as mechanical transducer. That transducer is called as mechanical transducer. Okay, is it clear? So mechanical and electrical. Can you tell me? Itna discussion hone ke baad, any one of you, can you tell me the what you mean by electrical transducer? Yes. Any one of you? Can you tell the electrical transducer definition?
Mechanical into electrical.
Mechanical into electrical or physical into electrical. See here, the last definition of the transducer, that is electrical transducer here. It is a secondary transducers we are going to call this one. It is not primary, it is a secondary transducers. which it is a device which converts any physical quantity or mechanical quantity into voltage or current or proportional to the input. Is nothing but it is voltage, current, these all are the electrical quantities only. Yes or no? Voltage is electrical quantity or mechanical quantity it is?
Electric.
Electrical. Current is electrical or mechanical?
Electric.
Electrical only. So the electrical transducer is a device which converts physical or mechanical quantity into electrical quantity. That is called electrical transducers here now. So the examples of electrical transducers are the thermistor, thermocouple, RTD, RVDT, solar cells, and these strain gauges. These all are the electrical applications or electrical transducers. We are going to call them electrical transducers. These all are here. So it completes the classifications of transducer. Only 4-minute time is left. In that one, we cannot explain this resistance temperature coefficient. See here, in this one again, the bridge circuit is there. Here under balanced condition, what is the value it is going to discuss. So we will discuss in the next class this part. RTD resistance temperature detector, it is nothing but previously we have discussed RTC, that is resistance temperature coefficient. Here resistance temperature detector we are going to discuss in the next class here now. Okay. Where it went? Just a minute. Roll number B division. A division you can leave the meeting. A division students you can leave the meeting. B division attendance please. Roll number 7. Are we there? Roll number 11. Roll number 13. 15, 17, 19, 21, 29, 31, 34, 35, 36. See here, I will get the attendance from the Zoom here now. At what time you have joined and what time you have left. That one also we will get that one. Total 1 hour duration. How much time you have present in the meeting. Everything will get the report from the Zoom. So some people they will think that one. Sir, mark join करके फिर left हो गए तो मालूम नहीं होते. Okay, don't do like that one. We'll get the report for student wise. You will get the report. At what time आप 10 बार join होके left हो जाओ, 10 बार इधर नाम आ जाते आपका. 10 times at this time around 10:12 he has joined, 10:13 he has left, again 10:20 he has joined, 10:21 he left. In time, out time, it is going to mention to us student wise. So for that reason, I am telling that one, don't miss the class. We'll take the attendance from there also for cross verifications. Okay. So we'll stop here only and we'll continue in the next class. Again, 1 to 2, I have the lecture. Don't miss that one. We'll discuss about RTD, RVDT and LVDT today. Stop here. Someone is connecting to the audio still. Roll number 39. Ajay. E division. Still he has not connected. Okay, no problem. We'll end here only.